have a lot of fun with it. I'm quite sure about it. The speaker is Alex, a friend of mine, who accepted to be here, and he will introduce himself very good. So thank you very much for being here, and enjoy his talk.
Yeah. Thanks. Thanks for having me. My name is Alexander. I'm working with a small consultancy, like 15 years. And I always like work with data and stuff. So I'm also involved in the MongoDB community. I'm running the our local mark. I'm just being appointed one of the MongoDB masters. And for the Python program chair at the EuroPython. For the EuroPython conference, I love hobbies and I like to learn new stuff. So that's why hobbies always like C above. Give a short introduction to Pandas. This is a framework for data analysis. I guess there's a method for everything you can think of. Yesterday I learned one method which was implemented. So it's a big, huge tool set. It's really fast and optimized. It works with frames. Some who work with R know the concept of data frames. You can reshape a lot of your data. You can in your code and actively work with it. It's basically having a relational database just like at the tip of your code. So it's high speed. The ED, very often here, we were going to use as something, and I'm going to introduce you a little bit to stats models, which is basically just a library for stats stuff. So let's do some life. So I'm switching my notebook and just going to give you a little fresh up what you can do. Pandas, how it works, just like a crash course. Yeah. Big off the top. We're going to lib and some. This I'm going to talk later about the data is sales from the iTunes Music Store, and clients and for the moment we won't do that. I'm on this machine, so I've taken the freedom on saving everything from the aggregation to a CSV up front. If you're interested in learning more about MongoDB and aggregation of MongoDB, I'm giving talk about that. So then let's just like get the data. So we are going to just like here use Pandas methods read CSV. You can read many formats to this thing like HDFS, whatever. It's really handy. So let's have a look at our data. So just read some data from a file. It's pre-aggregated data. I have mentioned activity, basically turnover, the zeros, and the data set is stored with years and months. So we only have monthly aggregated data for different. So, and these are, and I also have to disclaim, I've mangled a little bit with the sales data. It's not the real sales data because it's like confidence with my client, of course. So something really ugly here. It's like unnamed because I exported it with some index. We're not interested in this here, and how can we basically get rid of the column? In pandas, we just like delete it as we would delete something from a Python dictionary. We have a really nice data set. So, but yeah, it was just like a short introduction in the data set. So let's bring everybody again, just like import it. And what we can do, I'm just using NumPy to create some random list. Pandas is organized into, its data frame is split into. So it looks basically like this here. So it's a pandas series. You've already seen like it's like columns and looks like a table, but it's not like organized in rows. It's more organized in columns. And the column we call it's a pandas series, something like that. And the series also has a numerical or it can be multiple. If you have like a collection of pandas series, that's called a pandas data frame. And if you print it out, it looks like a table. So oh yeah, it's synchronous, very good. So let's work with some Landers paper and bring everybody on the same page. So I've created a random, just like some numbers. You see there's automatically, it creates a numerical index. And we also see it's stored as integer 64. It uses NumPy storage. You can have all various and then you have or just also like use some built-in methods like to datetime and build a datetime series. It thinks, okay, number, so it supposes it's a Unix timestamp. That's why it's all in the 70s here. But you can also all are the whole thing is a Boolean array. An array with true or false or something. So in our random example, we have like the first and the third is false. We can just like use series. We only get returned everything but the first and the third value from our array. So condition. So I just whatever which my series it returns a Boolean array again. So like fourth, the fifth value bigger than the mean. Is how we can work with theories, what we build theories, just like getting data. Let's build our data frame out of multiple series and like for creating a random list and a list of random lists. And basically it looks like this. We call the get these lists of lists frame, and we will use like multiple and whatever. It's flexible, but we won't. series, and they don't have names yet, and then it's auto-indexed. So give our columns and rows just like some numbers. So that's I'm lazy. I'm using string ASCII. And here we go. We've given our new index, and as you can see, the index can also be like a string, and all columns. Sorry, also have a name, just like, and so whole. Is this working? It's like, yeah. Can you hear me? For me, it sounds like, yeah. So, I mean. So, better now? Yeah, okay. So, well, we can get just like the distinct values. Distinct values there are with our unique. Also get the whole thing for a data frame. This and yeah. And of course, the next nice thing with pandas is it's like everything's built in. Batteries super included. So just like plot the data. Data set. We can plotting one of the series. So we just pull them like we pull plot our complete data set. Yeah, looks nice, but it's super. And we can also have types, just like built in. So yeah, this was just like super quick and dirty quick start. So we see we have quite mighty tool set at our hands. So now we're talking about time series and the use case. I ran into actually like time and everything is organized in our culture. So of course we have a year. A year is in 12 months, and as we see, the months have different. So for example, and basically everything feels like every month is equal. But actually it's not, because if you do some calculations, February is just like 90% of March. So, and I think that's like significant. It's not just, you can say each and every month, it's just the same if we have aggregated data in 1 month. Oh, that's going to be. Oops. Hello. So, oh yeah, that's better. So yeah, it's basically it comes from the Roman calendar. I hope there are not any astronomers in the room, because I'm really trying to explain it in a short time. It's the Romans only had like 10 months, and actually like for a period, and the year started in March. and it went until December. That's why December, or like September, September is like the 7th month, although it's the 9th month nowadays. And there was some period time of winter. Winter, who cares winter? Yeah, so there was no month for like a period of 62 days. So who cares about winter? Yeah, so. Yeah, it's crazy. So, of course, the whole system was reformed multiple times. There were they introduced 2 extra months finally, as known as January and February, because the whole system is basically based on a pie chart in the sky, which is the moon. And moon phase usually takes like about 28
days or 29 days until all the moon phase for a full moon phase. So the whole concept was based like on a lunar calendar, and then it was later changed to a solar calendar because the solar year is about like 365.24 days long. And after some reforms with Julius Caesar in 55 BC, things got quite close to where we are nowadays. But the thing was, there are multiple reasons, like being like even numbers being regarded as unlucky in Roman culture and stuff like that. February ended up like being like the trash month for everything. So if there was a problem with the calendar, just solve it in February. That's why February has like only 28 days. It's really funny. And basically like in 1582, it took that long. The Gregorian Pope Gregory reformed the calendar again to the calendar we know now, which is a little bit more accurate and is also like dealing with a lot of stuff. So, and there's a really funny explanation here. I've included a link. You can watch it on YouTube. It's 5 minutes. You know everything, where we come from. So what's my real life problem now? I got sales data. The sales data is from the iTunes Music Store. And turns out Apple is not using the calendar month to account. The whole Apple ecosystem is based on quarters, and these quarters are built out of 3 month or periods, and they usually start with a 5 week period, and then they have 2 more 4-week periods. So you get something like probably from the 27th of November to some date in December, and the data was saved in the database as being from any other source from a calendar month, like all the other sales data, because most of the shops and online stores account on a calendar month basis. So, yeah, that's we wanted to get some more insight into how digital sales work, what we can learn from that, and all the stuff. So I thought, yeah, well, it's super simple, just like some statistics to get insights. So let's do it. And so I thought, okay, yeah, let's use Pandas and StatsLive, and I'm going to walk you through what I've experienced. So again, this is like the Apple fiscal year. You see this 5 months, 5 weeks, 4 weeks, 4 weeks, 5 weeks, and it's also really important for any stock analyst to know that. In 2011, I guess, they totally missed that the first quarter had 2 5 weeks. So they were totally enthusiastic how Apple increased sales beyond their expectations, because they totally missed they had an additional week. Because so it's like, so. And this is the use case again. So this is like the typical quarter we're dealing with. And this is like a sales report. And as you see, this is like a sales report which was stored as being sold in the majority month, being like December here. But we have 1 day from January and 4 days from November. So for like time analysis, we need something like that. So something like even, straight line. So at first I thought, can I actually ignore it? Is it really that significant? So let's see. Okay, this is going to be some acrobatic now. So. So we're back at our Python notebook, and this is just like some. So I've already preloaded our aggregated sales data, and let's just like into a df variable, and let's just like inspect what we have. We have a huge data set of 78 rows, yeah, and we see it's stored like it's floats, integers, objects. basically everything in pandas strings are stored as objects. And we also should know we have an index already, is a range index, and that's going to become important later. And there's also a handy method like just like describe the data. We can just like have a quick view on what we have in our data set. It's not that exciting because it's a really small data set in our case. If you want to get rid of something we're not interested in, like in how many days since the year 0, we can just get rid of it. So now, as you see here in our data set, in our data set, we have a range index with month, which is just like one for January and the year. So we don't have a date there, and to work, let's use pandas apply method first to build a new series with a lambda function, and basically we just do it using like a datetime string to create a series, and we're just taking the two values from year and month and just combine them, just like super simple Python datetime stuff. And it gives us back a datetime series, as we can see here. We could also do it that way. So it's many ways. So this is, for example, we get a string back. So we did some string concatenation. And we could also use the simpler string concatenation and use the built-in datetime method from pandas to get a type datetime series. And since we just like took one series from our data frame and we created a new series, the series is the same length, so we can just add them to our data frame by assigning it a new name, year month, and it's easy as that. And now we can see here's it's stored as a date now. So, and for example, we can also just group the data, and describe what we have in our groups. So, for example, we see here we can even have for each and every entry in our year month column some more insight. So you can see we can also do a grouping by multi-index grouping. So we use the type and sales month, and here we go. So super easy to inspect your data set. We can also just group by something and just get the maximum values. So, and we can also see, for example, how many values are there, just using size and ordering. So we see we have 36 S and Bs and only 6 Ps. And the explanation is really simple. The data set we're working is 3 years. That's 12 months. So that's 36 month data. And P is actually for streaming. So last year in July, Apple started with streaming. So that's why we only have 6 streaming months here. Okay, some more Panda stuff. And you can also inspect what the index, what index we have. We can also do simple transpose. So it's all built in, and we can also for example, just pivot our data. Pivot, many might know that from Excel. I think it was always my favorite Excel function, pivot tables. The only useful Excel function I've ever loved. And it's really easy. Here you can build a pivot table. So back to our problem. So we have these sales data which which are accounted to 1 month, and they basically belong to another month. So how can we deal with it? And some other stuff from pandas, which is quite useful, is resampling the data. So again, let's look at our data. We have these, for example, like, we have this. We now have still a range index again, yeah. So because I've used another object, and datetime objects. So first, for resampling, I have to make sure I have a datetime index, because that's what Panda's going to use for doing the resampling. So let's have a look at our year-month column. That's all datetimes, and basically we can just instruct Pandas to reset the index, and we can just use one of our columns or like data series we have in place to set the new index, which is really simple. We just use the set index method and instruct it to just replace it. And a subtle but really important detail is here. You have to do in place true to actually have it reset on your data frame you're working on, because most of the times Pandas will give you back a new data series if you do something, and very often it's stored to a new variable. In our case, we don't want to do that. That's why the in place true is very important. So let's have a look at our new index, and yay, we have now a datetime index. And with the datetime index, we can resample the data. So this is just like, have a look, it's all dates, quite boring, and we can just like resample our data. There's like an extra, like, not language, but there are different patterns. For example, like Q is for quarter, so we can just drag resample everything by quarter. And as you see, like, resample is just deprecated. You have to use resample and put something in and mean to get rid of it. And for example, A is like for annum, so it's resampled by year. And usually you can also like use some more how can I say usually it assigns everything to the last day of the month, but you can also like instruct pandas to do it at first or whatever, but we don't cover it here. But for example, we can do also like doing something like, I want to resample my data set for like 7-month periods, and it's as easy as that. You can also like resample it for like 45 days, which is like 45D here, and that's also working. And my biggest question was, I have monthly data, or what happens if I'm missing data in my data set, if I have an unclean data set from sensors, and sometimes they don't send data, lose data, whatever. Can I resample it? Yes, no, yes, it's not that simple. So I can't just like take monthly data and resample them to one day, and pandas will do super magic and do it. But still, if you have a noisy data set, you can resample. So basically, I'm building I couldn't do it here because we have multiple. This is a little bit more complicated. So I'm doing a grouping by the index and just sum up, and then I can resample it by one day when using a forward fill. But we have to be careful because forward fill is just filling data with preceding data. So it's no magic. It's not like evening stuff out. So, okay. And then we have stats models we can use to have a closer look in our data set. And I hope this fits on the screen. So, again, here. Let's wait a bit. Yes, please. Yeah. So, this is like our data set looks like. We have, this is the data we observed. Yeah, so it's the 3 years. So hope you see that. That's we're starting in January 2013, and it's until December 2015. And we just see, okay, this is like the observed data, which is basically the turnover. Also have to see that's like we're not starting at 0. Yeah, so it's not just like, oh my God, it's totally dropping to 0. It just shows us a range. We see the trend. It's just like a trend calculation. And then we see seasonal. And this is where I thought, okay, now, doesn't really fit to what I know about sales data and seasons and when stuff is selling or not. This looks like, no, doesn't feel right. So that's when I basically came up, okay, I have to look a little bit more closer in the data. And so let's adjust. Let's even out our data set that we use real month again for exploring our data set. So back here. And just like a little reminder, our sales report assigned to the majority month, and we want even it out and taking some stuff to January and November in this use case. And basically, I've just written a helper function to ask for, okay, this is a certain month, and what's the ratio? How many days belong to the majority month? With how many days belong to the preceding and the following month? And it just gives me back ratio and some information, and I can work with that. So we have these days, and now the idea is basically splitting our data into 3 sets. One with having all the data in the same month, and we assign 2 new data series columns, like one for the ratio, activity new, which is like the turnover belonging to the same month, and we can use, that's a little bit over, and we can just like simply assign, we can just like simply use the apply method to get what we have stored in our activity as activity value, and just like multiply it by the ratio. So this is one of the really nice features in pandas. So if you have 2 series, you get like basically like 2 scalars, and you can just like multiply them. We could also like add them. In our case, we just want to multiply them. We get a new series back and store it back to our data frame. So let's do that. So we have 1 sold in the same month, and then we get another data frame sold in the next month, and then we get another data frame sold in the previous month. So, and now, for example, we have our indexes. Oops, where is it? Here, index is here, and all we've done so far, we only split the data. We've done nothing so far with like changing or telling our other data frame it belongs actually to the preceding or previous month. So there's a super easy way to do it in pandas. We can just go to, for example, let's have a look at the index of our data frame previous month. And it's really easy to build a new index. So we have an index made out of datetime objects, and now we build a new index. So we just pull this, we take this data series, we we get the index and use the shift method. And the frequency is the month. And why is it like -2 months? We want to go 1 month back. Happens that if you do -1, it adjusts like to the last day of the month. So we have to shift it by -2 months and add another month, because our whole data set we want to keep it at the first. So that's basically just the trick. So this is like -2 months plus 1 day brings us to the first again. So do that, and we get a new datetime index, and then we can just like go ahead and reset our index to the data frame, and that basically does the trick here. And now we have the 3 data frames And now it's really super simple. Let's take the three data frames and just like concatenate them and build a new data frame and regroup it and see what this brings us. So we have a new data frame now. We have like tripled number of rows. And it looks like this. And let's just like regroup, like basically like regroup everything again. So as you can see, we have introduced our data set is from 2013. So we have some data in 2012 now in December. So everything looks nice. And this is like our data set, how it looks like if we plot it by our new activity. We see we have a trend, but we have these like two nasty borders now because they only like are a partial month. Yeah? And also here we can do a resampling and plotting just like live by quarter. But I really want to get rid of these nasty borders now. And it's also super simple to do. So I have our regrouped data frame, and I can just like take the index and query, basically make a query. I just want date times between January 2013 and December 2015, because this was our original data set we are working with. And just like do it. And now things look really nice. Yeah, it's the same, but we don't have these. So yeah, another subtle. Yeah, and we can also like. Sorry, you don't see it. Here's a little. Oops. Ugh. It's like just like by quarter. Yeah, it's like the same plot. For those of you who work with Matplotlib, and your Matplotlib super experts, like the plot method from Pandas returns like the AX object, so you can even continue working on the on axis and everything, as you can see here. Because usually I would only get like a part, like the part where something's happening, but I think this looks weird for sales data because it always looks like something's going to the bottom, and so I just reset to have the y-axis start as 0, and as you can see, I'm getting plot back AX, and I can still work on the axis, reset it to 0, because this is what sales data usually look like, or like customers better understand it. So basically we've cleaned everything up, evened everything out. So I'm going to speed it up a little bit, and now we're going to do our stats analysis again. And this is basically what we get. So basically like our observations are as to expect, very similar, because we only have still the same sales data. Okay, thank you. We have a similar trend, but we have a very different seasonality here. Yeah. So, and it fits very, very well to what everybody, well, like we know about sales in the music industry. So, for example, this is January, and you see it's like, okay, there's like Christmas sale. Also notice it's just like a range. It's not like from 0 to whatever. Yeah, you just see like that it's moving a certain range, and we see, okay, yeah, there's Christmas, and there's like usually many new releases and sales in spring and in autumn, and there's a little bit like it's lower in the summer, and now it's Christmas again, and yeah, it fits well, and it looks much better than what we used to have before, because it was like really noisy, because we had like these 5 weeks, which just gave us totally destroyed basically the seasonality. Yeah, this is not a seasonality. This is just like noise. And this is the one thing. And there's also like the other shop involved in streaming. And let's get some data there, because there we have monthly data. It's a Swedish company. They account by calendar month. So we have a similar data set here. And just like, let's inspect it and see, just like as a proof of concept. So I'm just pulling another shop to see how the seasonality in the other shop is, just like as a test. Yeah. So of course, an assumption is sales in the music industry and or usage of music in the music industry should be very similar across multiple shops. So I'm just doing like I'm just checking out how can I plot the data and to compare it. And as you can see, for example, when reading my prepared CSV file in, it's also already a little bit simpler than before. We have some extra methods to prepare the data or get immediately the right data type into our data frame. And just like, let's have a look how it looks, just to get a proof of concept. I'm speeding up a little bit because we're running on time. So we see the range is smaller, but we still have similar. Same, but I'd say it's similar. Yeah. And okay, but that was nothing really new. Everybody would have known in industry anyway. There's a spring, there's autumn, Christmas, down, turnover was going down. So the question was, can we also learn something about like a specific product? Because like digital sales are very different to the physical sales nowadays, especially for a digital product, because you don't have any stock problems anymore. Because usually something would disappear from the market because nobody would take care to stock it. Now everything's digital. You have zero cost or almost to store something, stock something on a server. So let's see whether we can find something out about a product and give some insights or like quick insights and fast insights to our customers. So I'm reading a CSV just like for a certain product. And as you can see here, I can already instruct, please use the column dates as index and parse dates. So now Pandas automatically looks out for dates, what could be a date in a data set and convert it. So it's much easier than we had before. I just showed you the extended version to get you a little bit more into how things work in Pandas. So we already have everything here. We have a dates index. Everything's fine. We can immediately plot the activity of this product. So you can see, and this was quite actually a super simple analysis with Pandas, but with big insight. You see, okay, the product started, and then it went down, and then it went down. Of course, yeah, it's still selling, like for 7 years, which is quite amazing. Although sales are low, but you know, like in Germany, we say also like small animals make shit, so it adds up. So yeah, you see. But the interesting thing is, what is this? These peaks. And what do we know on these peaks? So is it like seasonality or not? And as we can see, just like, let's have a look. I'm just taking the data and let's see. Okay, yes, it's we have some seasonality, but it's only like smaller. This looks very different to before, but you have to take into account before we had like 3 years. Now we work with like a 7 years period. So these spikes, imagine it a little bit more extended, and it's really close to what we had before. And that's basically it. And then the other question was, it's sold at Apple. I still have these crazy, I have to fix my month, so let's do that. So this is just like the nasty stuff we did before or earlier. And let's get a plot and see what happens. And as you can see, before we had like really, and still also on this one product, a really noisy seasonality. And once we've adjusted or cleaned up or assigned the data to the right month, we have again a really nice, familiar seasonality. And yeah, that's yes, that's it. I just want to make some promotion, if I may, for EuroPython this year in Bilbao. We will have a second call for proposals for hot topics and recent events, and we call in the first weeks of June. So we made that to cope, to deal a little bit with like publishing schedule early and so much stuff happening nowadays within like weeks' time. And if you're interested in data mangling up front with MongoDB, I'm going to speak about it tomorrow at 5:15. And yeah, thank you.
Perfectly in time again. No chance to use that panel. Too bad. Anyway. Sorry. Jokes. Any question? Sorry.
Did you work with some data when you did the monthly aggregations? And my question is, isn't then there an unfair comparison between months? Because like if you analyze January and February with some data, there were like 10% more days in January than in February. That maybe if you use like averages, still the comparison would be unfair because you would have a higher variance, for example. But the fact is that like this, you risk to catch this variation in the length of the months in the trend analysis. How does the analysis prevent that?
Yeah, actually, you're 100% right. And here we did not really fix the February. So, but if I would do something like, yeah, usually it would be another step. I just thought, okay, I just concentrated on these very on these crazy Apple weeks, yeah, because it's a little bit more, it's easier to illustrate, because yeah, we only have like, it's 10% between like February and March, but the effect was bigger, and that's why I chose this way. But you're absolutely right; it would do the same. Yeah.
Hi. Are there any tools included to compare time series or cluster them according to their behavior, to know if they're similar, or you can do it on your own, but I just wanted to know I had issues with that.
Actually, yeah, I can use it, I think. Actually, at the same question, I haven't discovered something yet, but if somebody finds something, please let me know. But the pandas ecosystem is huge. It might be built in. Okay, this is my game.
Questions? Okay. Thank you, Alex, very much.
Thank you.